and we were working on a separate project. And the customer came down and he goes, "Hey, is there any chance your magical stuff can work in here instead of doing all this other work?" And I was like, "Yeah, I mean, I can't see why we couldn't fixture this up." And that was back in 2016, and that thing is still running today.
Wow.
Most people think manufacturing's dirty, boring, or dying. They're dead wrong. This is Manufacturing Runs the World. We're here to fix the misconceptions, teaching the next generation how modern manufacturing really works and why it matters more than ever.
So I was digging a little bit and saw in some of your YouTube videos of other, it's nice getting manufacturing out there.
It's interesting not to try to crack and tell that story, having been on the marketing side for so long and just hearing manufacturers from a marketing perspective kind of talk to themselves a lot, about features and benefits and stuff. It's been nice to kind of like talk directly to either manufacturing owners or directly to engineers about the stuff they do and how it affects people. So there's also the story of manufacturing tends to have this dirty and dingy perception, right? Heavy hands-on manual labor.
Everybody just thinks of like Men Who Built America and Carnegie Steel, like that's manufacturing. It's like, that's not always manufacturing.
Yeah, especially these days, it's like, it's much more user interfaces. It's much more technically driven. Sure, when you get down to the machining side, all that comes down to a machinist who is well skilled in that particular thing. But there's so much engineering and design that happens before it gets to that point.
And trying to keep that simple too, like Elon's push right now of just saying, keep it simple to manufacture, don't overcomplicate it. And like you see some of these prints, these younger engineers doing, you're like, how are you going to hold that? Or how are you going to do this? It's like the machinist turns into the engineer because he's got to fix stuff to make it easier for himself. And that's just time lost, just errors just stack up at that point. We're going through like reorganization, kind of like not rebranding ourselves, but like trying to really get our message out to what we do here. We're in the machine tool sector, right, and we actually manufacture, we do repairs for machine tools. So it's be either rebuilders or OEMs, and we sell products that those OEMs can use or rebuilders can use. So we do work a lot with engineers integrating our products. And one of our bread and butters is a wayliner material. And there's a lot of different types of wayliner, like way systems. You have hydrodynamic, hydrostatics, you have linear ways. And where we really come to fame is that you can actually get cheaper precision with our products. So instead of having to grind multiple surfaces or actually hand fit surfaces, you can use our product called Moglice and actually will replicate the surface you're looking to ride on. So we work a lot with design engineers and machine tools to try to think outside the box when they're thinking about rigidity, when they're thinking about reliability, and just trying to be more efficient in the machines. So we have definitely a lot of, that's like our bread and butter where we are. And the one thing where we really shine is we can do some of these techniques that we do here at the shop on site. So if you have like multi-billion-dollar operation and you got key components that go down, our techniques can keep the window of downtime to a minimum. And those machines, if they go down, they're like a day or two is like killing them, So some of these OEMs are coming in and saying, hey, to actually fix this properly, we're going to need like 2 or 3 months. They're like, there's no way we can survive that.
Right.
We'll come in with like a week or two and like a shutdown they could possibly get away with and help them fix their problem. A lot of that technique and speed comes from the Moglies. So one of the biggest things that we can requalify surfaces for the precision parts of it, and the Moglies will replicate to that, like remachine or rescrape surface that we can do on site.
Yeah.
And that's where our speed comes up because once we mold to fit, there's no additional work that requires in fitting to make sure the precision's there. And a lot of those machines where precision makes sense is to actually have the reliability of the machine going forward. So some of our stuff that we've done, we have proven that, we've done in the early 90s and it's still running to today's standards.
Yeah, that's cool.
And you were able to do that within under a 2-week window. So manufacturers are like, oh my God, how can you do this? Like everybody's telling me like months.
Right.
So,
You sound like you're involved with sales.
yes. So I kind of wear many hats here. I'm involved with the engineering side and sales side. And I've been here for like going on 13 years.
Tell me more about that. How did you start? You've been at Devitt the whole time?
Yeah, so I went to college, and after college, I was interviewing through basically LinkedIn, and I found Devitt Machinery, and I was hired, and I've only been, here ever since. When I first started here, I started seeing the opportunity with the customers because we were, across a lot of sectors. So we were in aerospace, automotive, steel mills, and I'm like, man, like this is crazy. And then I start seeing some of the jobs and then the opportunities that I could take, and I was like, really infatuated with that.
Yeah.
So kind of why I stuck with it. And then I kind of put myself, even after college, I kind of put myself through like a machine tool and die repairman kind of like apprenticeship, because you had to learn how to machine. You had to learn to make like fixtures and stuff to set up like for the products. Then you had to learn how to like, you went through a whole nother level of engineering. It wasn't just the machine tool side is just like, in my personal opinion, a next step in engineering, because there's so much precision involved. But it's not just like creating a model and creating a drawing. It's like why those things work the way they do.
Right.
That was a fun challenge to learn.
One day doesn't necessarily look the same ever.
You could be pulled in a million directions. And I mean, the other thing that is really common is a customer that's local call us and say, hey, we're down. We need you to help us out. Like, can you be in here? That's not uncommon. Yeah. And then you're like trying to figure out how you can come to the rescue to keep them going.
Yeah.
At least looking the solution. Right.
Doing your regular everyday stuff, but you're also like Ghostbusters if a problem happens.
Yeah, we've solved some interesting problems. I mean, one of our customers had a big giant crankshaft. It's to a big shear. Mm-hmm. And there were a point on their coupling and pin that it was about to roll. And when they got the quotes back for what it was going to take to make a new one, it was like close to a year. And they were like, whoa, this is like, very important piece of the equipment to the line. It can't go down. And we were actually on site doing something else for them.
Yeah.
And so a typical day when we're on site, we're trying to focus on our task. And they had another company come in. They were going to do all this machining. They were going to kind of like try to make it work with like welding up plates, building back the surfaces, trying to see if they can fix what their problem was. And we were working on a separate project. And the customer came down and he goes, hey, is there any chance your magical stuff can work in here instead of doing all this other work? And I was like, all right, well, I made sure my guy was good doing what we were supposed to be doing. And then I walked down and tried to check out what they were doing. And I was like, yeah, I mean, I can't see why we couldn't fixture this up, align it, and just shoot it with our product. And that's what we did. And that was back in 2016. And that thing is still running today.
Wow.
Like that. And it took them over 2 years to get the replacement parts in from the OEM.
Okay. So paint this picture to me as if I'm in 6th grade. It's a big giant shear, right? So it's
a big giant shear. It shears about 8 inches of aluminum thick.
Wow.
It's about 8 foot wide, and it's 8 inches thick, and it could be really long at that point. It could be close to almost like 100 foot because it's starting off as a real big block of aluminum. And they roll that out to where it gets around 8 inches, and there's these big butt swells at the end. So the shear, it will come in and the shear will cut that off.
Right.
And up top, there's a big crankshaft. So it's concentric, so roll. And there's a big giant coupling on the end here. So it will turn it with these big giant motors in another motor room. So once that coupling turns, it turns to this crankshaft and it lifts it up and it drops it down so it can shear. Yeah. So that coupling was about just to roll and no motion was going to happen because it was so severely worn. Yeah. So all we did was just fixture it in position and then inject our DWH in there, which is our static precision sim, basically. So it just filled the void that was all worn away. And then it glued itself, basically.
Wow.
Now it's one unit to where that coupling will still pivot on its swisher plates, which are just basically just grease-packed bronze liners that are able to like move. So when the crankshaft comes up, it can actually like pivot. Yeah. And yeah, that was back in 2016 that we did.
That's crazy.
Strong. And the fix that, so that was the biggest problem was getting the parts in, it was no one ever had that apart. So it was like, and it's not like you could call somebody up because the manufacturer doesn't exist anymore.
Sure.
So they were like, how do we take this apart? Do we even have the crane capacity of height to pick it up, like to take it apart, lift the top casting off, like all this other stuff? And then they were like, who? The hard part was who was going to own it? Like who was going to be the person to do that to meet a deadline? And everybody's like, no, we don't. Like that sounds like a suicide mission for a company, right? And then we were like, well, why don't we try it? Because if we try our stuff and it works, great. If it doesn't, then maybe it buys you time to get the piece and an engineered plan to figure out how we're going to take it apart.
Yeah.
So that was like one of our craziest, like that happens when we're on site. We get pulled in many directions, but that's one of like the successful ones that was like, man, that was really cool that happened, and we kind of show into that. Because our new thing right now, we're building orbital surface testing plates for startups and for like deploying satellites or assembling things in space, and they want to simulate space. So instead of paying like 20-30 grand for like a granite surface plate, we're actually building them a little aluminum extruded base and pouring one of our Moglice products on top, making a flat surface.
Cool.
So then what they do is take air bearings from our sister company, New Way Air Bearings, and they actually make this like little tripod up or with little boosters on it, and then they can kind of just simulate anti-gravity and kind of like simulate docking and things like that nature. The products puts you in a lot of different worlds.
Yeah, that has to be super fun.
That's the intriguing part that gets you hooked, because you're like, well, it's not like I'm dealing with dirty machine tools all day. Now you're dealing with a clean room. And you're like, this is nice.
Yeah. Is that with NASA, I assume? No. Well, if it's satellites, it doesn't have to be.
Yeah, we worked with like Blue Origin, SpaceX. We talked with SpaceX. We actually delivered some for Blue Origin.
Blue Origin that's Amazon's.
That's Jeff Bezos, right?
Yeah.
They ordered two from us. They wanted one in Washington and one in Alabama.
Yeah.
But what's nice about those is, especially with the like engineering students and like a building and stuff, and they got like this little lab, instead of like, you're not going to truck a granite plate up there, especially on the size that they want. The beautiful thing about this is you can kind of build what you want in your room and then pour it. Right. And then now you have this surface to deal with, like to actually simulate with. So that's like really intriguing too for kids, like younger generation engineering students, which just need to kind of play with. I remember when I was growing up, like you had to go to college, you had to go to college, you had to go to college. Like if you were thinking about trade school, you were like looked down on, and it's like, no, that's not, college isn't for everybody. Obviously college is useful, and you want to make sure you're going to college that you're going to actually do something well with it, because it's an investment. And I felt like for my generation, or just the people around me, like I don't really feel like that was like, hey, you're going to spend a lot of this money, so make sure you get a good job to pay it back. Younger people just saying, hey, I don't want to go to college, but I want to learn. And that's been successful. It's nothing wrong being a machinist or being an electrician, or, just the people that we need to like scrape ways in, or just apply products and stuff. Like that's meaningful, and you do something that's outside the norm. Right. It's cool. I mean, these engineers that I've also dealt with that seem to be very sophisticated and high, like knowing a lot or anything else, the really good ones work right besides the guys that they would call the millwrights or the roughnecks or the machinists, or being right there with them. Those guys like are 10 times better than anything else. It's insane. When you can kind of bridge that gap and understand that and learn from some of those guys on the floor and actually understand and try to make their life easier, the more that that's a recipe for success right there. And sure. I feel like there's such that disconnect between like the machinist and the engineer.
Yeah, in some cases for sure. But yeah, if you can bridge that gap, that's usually a recipe for success in many of the engineers, machinists, and owners that I've talked to, where they have those people able to sit next to each other is usually the best outcome. Cody, I want to be mindful of your time. We're about 5 minutes over here. Is there any parting things you want to say about Devitt?
Keep looking out for us, because we're going to be having a good social media presence, and we're going to be growing. So I can't wait to keep sharing, the mission here and showing our success.
Yeah.
Awesome. Thank you very much.
Awesome.
It was nice meeting you and good podcast.